All right, let's dive right in. We're talking about one of the most crucial and honestly one of the most fun parts of data science, exploratory data analysis. You'll hear it called EDA. So what's the big deal with it? Well, I want you to think about any dataset like it's a mystery novel. It's packed with clues, hidden stories, you name it. But how do you get it to actually talk to you? How do you piece all those clues together to figure out what's really going on? Well, that's what EDA is for.
Okay, so what's the textbook definition? EDA is basically using visualizations to summarize the main characteristics of your data. But here's the thing, and this is super important. It's not just about making pretty charts. It's really an investigation. It's like having a conversation. You ask questions, and the data gives you answers back in the form of pictures.
And every good detective needs their toolkit, right? In Python, our main tools are matplotlib and seaborn. Matplotlib is like your foundational kit. It gives you super fine-grained control over every little detail of your plot. Then there's seaborn. It's built right on top of matplotlib, and it's like the specialist tool. It's designed to create these beautiful, really insightful statistical graphics with way less code. Often it's just one line. Okay, so where do we start our investigation? Well, the first step is always to just look at the evidence you have, one piece at a time. In data terms, that means looking at each variable or each clue all by itself. We call this univariate analysis. So let's ask a really basic but fundamental question. Let's say we've got some customer data. The first thing we'd probably want to know is, who are these people? And a great place to start digging into that is their age. And boom, here's our first clue visualized as a histogram. It's pretty straightforward, right? Along the bottom, you've got the different age ranges, and going up the side is the number of customers. The taller the bar, the more people in that age group. So just at a glance, you can see exactly where most of our customers are clustered. Okay, now this is cool. Look at this comparison. On the left, that's a classic matplotlib histogram. On the right, that's from seaborn. You see that smooth line flowing over the bars on the seaborn one? That's called a kernel density estimate, or KDE for short. Just think of it as a smooth curve that helps us see the underlying shape of the distribution. It gives you a much better feel for the pattern than just the blocky bars alone. All right, so we're getting a handle on who our customers are. So what's the next logical question? Well, what are they buying? What stuff are they actually interested in? Let's find out which product categories are the most popular. And for that question, a bar chart is the perfect tool. Simple as that. Each bar is a category, and how tall it is tells you how many people bought stuff from it. I mean, look at this. You don't even have to think about it. Clothing is obviously the biggest seller. It's just so direct and effective. And this is a perfect example of why Seaborn is so awesome for this kind of work. It has a tool called CountPlot, and what it does is it automatically counts everything up for each category and draws the bar chart for you, all in one go. It just takes care of the grunt work, so we can get straight to the interesting parts. Okay, this is where the investigation starts to get really interesting. So far, we've just been looking at clues one at a time. Now, we're going to start connecting the dots. This is called bivariate analysis, and it's all about finding relationships between two things at once. This lets us ask much deeper questions, like, is everybody spending about the same amount of money, or are some groups spending more than others? For example, let's ask, how do purchase amounts compare between men and women in our dataset? For a question like that, the box plot is your absolute best friend. Seriously, it packs so much information into such a simple little shape. See that line in the middle of the box? That's your median, the typical purchase amount. The box itself? That shows you where the middle 50% of your customers fall. It's amazing because you can instantly compare the typical spending and see how much that spending varies between the groups. And really, that's the main takeaway. A box plot is just an incredibly powerful tool for comparing how a value, like spending, is distributed across different groups. Super, super useful. So we've been looking at clues one by one, then in pairs. But what if we could just step back and see the entire investigation board all at once? All the evidence, all the connections just laid out right in front of us. You know that classic scene in a detective movie, right? The big corkboard on the wall, covered with photos, newspaper clippings, and red strings connecting everything? Well, believe it or not, we have a data visualization that does pretty much the exact same thing. It's called a pair plot. And honestly, this is where a tool like Seaborn just absolutely shines. With literally one line of code, it creates this incredible grid that shows you the relationship between every single pair of numerical variables you have. It's the ultimate bird's eye view of your data.
So, how in the world do you read this thing? It looks complicated, but it's not. First, look at the diagonal running from top left to bottom right. Those are just the histograms we saw earlier, showing the distribution of each individual variable. But the real magic? That's in all the other squares. Every single one of them is a scatter plot comparing two different variables. This is how you spot relationships instantly. See a bunch of dots forming a line going up? That means as one thing goes up, the other tends to go up too. It's just an instant overview of your entire data set.
Okay, we've looked at the tools, we've looked at the techniques. Let's wrap this up by putting it all together into a simple workflow you can use to crack any data case you come across. It's a really logical process. Step 1, always start with questions. What do you actually want to learn? Step 2, univariate analysis. Look at each piece of evidence on its own with histograms and bar charts. Step 3, bivariate analysis. Start connecting the dots between pairs with box plots and scatter plots. And finally, step 4, and this is the most important one, iterate. Your findings are going to spark new questions. You just have to follow the clues. And please remember this if you remember nothing else. EDA is not a straight line. It's not a checklist you just run through. It's a cycle of discovery. You ask a question, you make a chart, you find something interesting, and that discovery leads you to your next question, and on it goes. Because when it comes right down to it, that's the whole point. The objective is to really deeply understand your data. You're looking for patterns, you're spotting things that look weird or out of place, and you're generating those aha moments, those insights that can change your business or help you build an incredible machine learning model. So yeah, your data is talking. It has stories to tell. With these tools and this kind of detective mindset, you can be the one who finally hears them. So the only real question left is, are you ready to listen?